Welcome to the class. In today's class, we are going to study fundamentals of logic, that is basic connectivities. Let us understand what is logic. Logic is a science that deals with the methods of reasoning. Reasoning plays a very important role in every area of knowledge, particularly in the field of mathematics. Logic basically expressed in the form of symbol, that too in precise and unambiguous terms, is called as mathematical logic or symbolic logic. Let us look into the definition of propositions. Any statement or a proposition is a declarative sentence that is either true or false, but not both. And uppercase letters, alphabets, are used to denote proportions. We will see the example. 2 is an even number. It's a statement. We call this as a declarative statement which has a true value, because we all know that 2 is an even number, true statement, and it is denoted with capital P. Similarly, we have another example. 7 is an even number, which is having a value as false because it's an odd number, so it is a false statement and it is denoted with Q. We will consider another one. A is a oval. It is also a true statement, therefore we denote it by capital R. Similarly, we will see some statements which are not proportions. My cat is beautiful, and it is denoted as P, but you cannot say that whether it is true or false. Okay, without any measurement you cannot, or relative comparison, you cannot say that that statement is true. Similarly, my house is big. Without any relative comparisons, you will not be able to conclude whether the statement is true or false. That's why these two are considered as not a proportions. Next is a variable used for proportions are PQRS, and the truth values we use is T and F. F for false, T is for true. A simple proportion, we call this as a simple proportion. From simple proportion, we will be able to create compound proportions. Logical connectivities or connectives and truth tables. We will look into first logical connectives. It is called as negation. A negation of P is written in terms of the symbol. Negation P is the statement obtained by negating the given statement P. So we see an example for this. A is a consonant, that is my statement, that is denoted with P. So how do we write negation P? It is a case that A is not a consonant. So when you include this keyword not for the appropriate place in the given statement, then it becomes negation of the given statement. The truth table looks like this. P is a statement having two values, 1 or 0. If it is 1, when you apply negation for 1, it becomes 0. If it is 0, when you apply negation for 0, it becomes 1. This is a truth table. Moving on to conjunction, the second connectives. Let P and Q be any two statements. The conjunction of P and Q is denoted with the symbol P cap symbol with Q. Is a statement formed by joining statements P and Q using the word called AND. These connectives can be used to create compound propositions. The statement P and Q is true if both P and Q are true, otherwise P and Q is false. As per the meaning of conjunction. The truth table of the conjunction looks like this. We will take P and Q in two different columns. Sorry. We will consider all possible combinations. Initially both are false. Next we take Q as 1. Next we take P as 1 and both are 1. In that case, according to the definition of conjunction, when both are true, the conjunction value is true, rest all values it is false. We will see the example as an illustration. Let us consider the following proposition. P is square root of 2 is an irrational number. Q is 9 is a prime number. R is all triangles are equilateral. S is 2 plus 5 is equal to 7. We can start writing this. P and Q, how do you write? Write P statement as it is. Include AND keyword, then followed by Q statement. That's all you have to do. Square root of 2 is an even number and 9 is a prime number. Just place AND keyword in the appropriate position. You can try other 3 on your own. These are all called simple propositions and these are all called compound propositions because it has a compound keyword. So this is how you get results. You can also find truth value of all this by considering the truth value of individual statements. We are moving on to disjunction. Let P and Q be statements. The disjunction of P and Q is written by P or Q. The symbol used for disjunction is OR symbol. Using the word called OR to the appropriate place or between P and Q, we write disjunction. The statement P or Q is true if at least one of the statement PQ is true. Otherwise, it becomes false. Truth table for disjunction, as usual, two propositions are taken and its OR can be written as if any one of the value is 1, then you get 1 as a result, otherwise it is 0. We are moving on to example. Let us consider same example. How do we write P or Q? Square root of 2 is an irrational number or 9 is a prime number. That is how you write. Similarly, you can try other, just placing OR keyword in a between two propositions or here, and also you can try to find true values. Exclusive disjunction is another proposition connectivity. It's denoted with the symbol or with a line under that. Here the compound proposition P or Q to be true, only either P or Q is true but not both. The exclusive OR is denoted with the symbol. So what do we get? Any one of this value must be 1 to get 1 as a result. For other cases it's false. In the similar way, you can just try with all these examples. The word keyword to be used is either in the beginning of P or in between two proportions, but not both at the end. That is how you write. This is your P and this is your Q. So either P or Q, but not both. That is how you are going to write using exclusive disjunction. In the similar way you will write for all. Try yourself and also find truth value according to the truth table. Okay, that completes basic connectivities. We are moving on to implication and other in the next class.